Hello, this is Farhan Khan from the Republic 2.0, and today we've come up with a new topic, and that is the topic number 1B from the Unit 1 of Edexcel Physics. And the topic is all about the force and the power. So, whenever you're talking about the force, force is basically a push or a pull, right? Where everybody knows that force changes the state of an object, it brings a body from rest to the motion or from motion to the rest. So we'll be talking about all of these things, but before that, we'll be talking about the work done. So work done, what is the work done? When a body is said to be doing work, a, an object, an object is said to be doing, an object is said to be doing work if force acts on it and it covers displacement in the direction of force. And it covers displacement in the direction of force. That is what you call the work done. So whenever you're talking about the work done, a force must act on an object and it should be covering displacement in the direction of the force. And the first question is, what if the displacement is not in the direction of force? So what we're going to do now? For example, this is the floor and we've got a block over here, and that block is tied with a string, and that string is being pulled in this direction by a man who is walking ahead of it. So everybody knows that when we're pulling the block like that, the block would be moving in this direction. So that is going to be the displacement, and that is going to be the direction of force. But the thing is that the object must be applying the force, or the displacement must be completed in the direction of the force. So you can see that if you want to calculate the force component, which should be in the direction of displacement, that should have been the horizontal component of force. So what would the work done become? It would be F cos theta times D. So work done comes out to be FD cos theta. So everybody knows to make sure that whenever the work is being done, there are three conditions for that. First of all, there should be some force acting on it for sure. The body should be covering some sort of displacement, and the theta should be, force, and theta should be in a way that force is parallel to the direction of displacement. So that is what is theta. And right after that, whenever you're talking about such stuff, whenever you're talking about that force should be in parallel with the displacement, and you're talking about theta in that case, the next, let's talk about an example to sort that out. For example, you're carrying a bucket that is filled with water on your shoulders and you're just walking in this direction. So basically, to carry that bucket, you are applying force in an upward direction. So this is the direction of force and this is the displacement. So now everybody can see that, the force is being acted, the displacement is being covered. So if you want to calculate the work done, it should be F times D times cos theta. Now, everybody knows that there is force, there is a displacement, but there is no, um, angle. The angle is 90 degrees. So the work done comes out to be zero. So in that case, despite the fact that force is being applied, displacement is being covered, there would be nothing, no work done. Why? Because the theta comes out to be zero. So that is the work done. Whenever you're talking about the work done, we have to sort things like that. Now, the second thing that we need to know, that work done can either be positive or can either be negative. If the theta ranges between 0 to 90, or if the theta ranges from 90 to 180. Remember, in that condition, the work done would be the positive work done, and in this condition, the work done would be the negative work done. So that is how we should be talking about the work done, from 0 to 90 or 90 to 180, right? From 0 to 90, the work done should be positive. From 90 to 180, the work done should be negative. Now, the thing is that, how can we calculate the power by just using the work done? So, everybody knows that the power is the rate of change of work done. So work done divided by time. We're just trying to sort out a relationship between the power and the force. So what we are going to do, everybody knows that work done, the maximum work done should be force times displacement divided by time. And if you want to calculate that, the power comes out to be, the expression for the power can also be written as F times d upon t. So in that case, the power would be F times velocity, because distance of and time is velocity. So by just having the force and speed, you can actually get yourself the power. The units of power would be the same thing. It would be simply be the watts as well, right? So we have to talk about like that, right? So whenever you're talking about power, you have to sort it out like that. Now the next topic, probably the last topic in the B part of the mechanics, and that is the efficiency. Now the thing is that what factors tells you about the efficiency? So whenever we are talking about the efficiency, efficiency is basically how efficiently a machine is working. For example, if I'm talking about your car, you're giving a input energy to the car in the form of the chemical energy. Suppose let it be 100 joules. This is car A. And that car is giving you an output work done of 90 joules. And then there is a car B. You're giving an input energy to car B, which is also of 100 joules, but that car is doing an output work done of, for example, 70 joules. So this car is said to be more efficient than this one, right? Because you can see the ratio, the ratio is smaller as compared to the A1. So whenever you're talking about the efficiency, efficiency is just about the output, output work done divided by the input work done times 100. So, if you're just going to calculate that output work done upon input work done, output work done can be calculated by any way. For example, you've got anything like 90 upon 100 in this case and 70 upon 100 in this case. There would be no units of the efficiency because both that is the ratio between the same quantities. Apart from that, you can also calculate the efficiency by just comparing their powers. For example, I'm talking about the output power and then I'm talking about the input power. So by just comparing these things, I can calculate their efficiencies as well. So that is how we should be talking about these things, right? So that was the last topic from the work done, and we should be uh, doing a worksheet or a topical from this chapter later on in the video. Thank you very much. Please like, share, and subscribe to the channel. Goodbye.